I'm going to start. We have done up to now, this is a kind of review. We have Should I phone for an ambulance? No. Oh, you're good? Okay. Yeah, worry about it. So the other day we talked about average velocity, displacement, average velocity. I think all the graphs were all straight lines too, weren't they? When we did average velocity, were they not? I think we've only done straight lines. Yesterday we talked about speeding up and slowing down and the actual shape of the graph. So today we're going to look at what we call instantaneous velocity. Now back at the start of this unit, I introduced you to the idea of a time instant and a time interval. So when you do average velocity, you're talking about it's over a interval, right? But instantaneous velocity means what? What does instantaneous mean? Like now, right? When you're driving along the highway and you look down at your speedometer, that is your instantaneous velocity, your instantaneous speed. How fast are you going right now? Your average speed might be something quite different, right? How you speed up and slow down. So now we're going to try to find out how to calculate instantaneous velocity from a DT graph. Oh, and it says right here. So far we've determined displacement from a DT graph. How do we do that? Read 2 points off the graph and subtract. So just read those y points off the graph. Determine the average velocity from a DT graph by dividing displacement by time interval. Okay, so now we're going to look at instantaneous. So here we've got intervals A, B, C, D, E, and F. Do you sense clicker questions coming on? I do. First, let's review. What have you got there? You got a little review there? Okay. So I want you to find the displacement and average velocity for intervals A, B, C, D, E, and F. When you find average velocity, again, basically you're finding the slope, right? You're finding the slope. So go ahead. Actually, you know what? Don't even bother with displacement, because to get the average velocity, you have to find the displacement, right? So just find those slopes for intervals A, B, C, D, E, and F. And you might struggle a bit with F, and that's okay. Go. I'm going to go do attendance. Should I do the first one as a reminder? Okay, how about I do the first one? So the average velocity for interval A from 0 to 2 seconds. So we're talking about this one right there. Now, do you have to pick the endpoints? Do you have to pick the points that are on the end? How come? Because it's a straight line. Does the slope of that line change? No. So any 2 points are going to give you the same value. Traditionally, by convention, most people pick the endpoints. That's okay, but you don't have to. Okay, so what are these 2 points? The point at the start here is at 0, 0. And what's this point right here? 2, 6. I think you're right. Right? So you take the y values, which are 6 and 0. So it's going to be 6 minus 0 over the x values, which are 2 minus 0. So it's going to be 6 over 2, or 3. 3 what? Meters per second. You're right, Vinny. It's the speed. Is it a constant 3 meters per second? Absolutely. How can you tell? Straight line. Is B a straight line? Yep. Okay, so go ahead and find the slope for B, C, and D, and E, and F, and I'll do them with you in about 3 or 4 minutes. How are we doing? Should I do a couple? Well, B, what's the slope? 0. Do you even need to do it? How come? It's flat line. 0, right? You shouldn't have to do that one. And that's going to be the same for D, is it not? Okay, so that eliminates 2 pretty quick. So C, it's a negative slope. You're right, it's down. So let's just find these points again. So that's going to be 6, 6, it looks like. And this one down here is going to be 10, minus 10, right? So the slope here is going to be minus 10, subtract 6, which is minus 16. The displacement is minus 16. You're ahead of me there, Vinny. The time is 4 seconds from 6 to 10. So 10 minus 6 or 4, and so it's a slope of minus 4 meters per second, right? Everyone's good? Yeah? Can do that? Hunter, is this within what you guys were talking about a little bit? Yeah? Awesome. Okay. E is from 12 to 13. It's really steep, and it's positive. This point right here looks like it's at 10, 11, 12. Looks like it's at 13, comma, minus 4. And this one here would be at 12 minus 10, right? So this is going to be minus 4, subtract minus 10, which is a plus 6. Does it go up 6? Yep. And from 12 to 13 is just 1 second, right? 13 minus 12 over 1. So that's going to be 6 meters per second. Now, what do we do with F? In the graph, the slope of the line in time interval A would yield the average velocity for that time interval. In general, the average velocity is the slope of the line joining the endpoints of the time interval. This is true for straight lines and curved lines like interval F. So what is actually happening? I'll clean this up a bit. What is actually happening in segment F here? It's slowing down. But it still has an average velocity, right? How do you find the average velocity? You simply connect the endpoints. That is the average velocity. At the start, it's more than that. At the end, it's less than that, right? But the average is that slope. Okay, so how would you do that? Just connect the endpoints, find your slope. This is going to be 0 minus minus 4, which is plus 4. And we're over, I can just count them, 1, 2, 3, 4, 5. So 0.8 meters per second. Okay, does that make sense? Good luck, Lana. So here's the new stuff. Instantaneous velocity is the slope of a line at a single point or a time instant. The slope at a single point. Well, how the heck can you do that? Because to find slope, you need 2 points, right? Hey, stay with me. Slope of a line at a single point. Well, first of all, it's easy for straight line segments. How come? Because if the slope of the line doesn't change, then the v-inst is simply the slope of the line, right? In other words, if I'm asking for the slope right there, or right there, or right there, or right there, it's all the same, isn't it? The slope is the slope, right? Since the slope remains constant. So really, instantaneous velocity on a straight line is simply find the slope. It's easy. What about slope of a curved line segment? How do I find the instantaneous velocity at a single point right there? Colby, you should watch. Your mom's not going to help you with this unless she's a physics teacher. I guess I should have checked that before I said that. Oh, she's not. Then you should listen to me. I'm going to tell you to find the slope of the tangent line. You guys know what a tangent line is? When a teacher goes off on a tangent, what does that mean? I do it lots, by the way. Like, for example, there was this one time. When I go off on a tangent, what am I doing? Off topic, off on a path that is not where we're supposed to be going, right? So if this is the path that you are supposed to be headed on and I go off tangent, I'm going off somewhere else, okay? But a true tangent line at a single point is, do you guys have something on the next page? A tangent line only touches the curve at one point and estimates the curve at that single point. That is the definition of a tangent line. It only touches the curve at a single point and is an estimate of the curve at that single point. It's an estimate of the slope, is what it should say. So, for example, right here in this picture, looks like you guys need to fill in some blanks, do you? I apologize, I'm going fast. Tangent line only touches the curve at one point, estimates the slope at that single point. And you guys you're doing this on me right now, aren't you? Well, I guess I can wait for you to do it. How do you draw a tangent line? You take your ruler. It's hard for me to show, because for me to do a ruler on there, it's kind of hard. So you literally, I'm going to do it on the screen. You literally take your ruler. If that's the point right there, you take your ruler, and you put it on there so that it just touches the line at a single point like that. See how I did that? Why not like that? Because it's going through, like, right? It's got to touch it at a single point, and it has to match or estimate the curve of the line. It's really just an estimate, that's all it is. Okay? You're estimating the curve at that single point, and then you draw that line as long as you need to, and then do what? Find the slope. Okay? It's exactly the same process as before, except you have to draw the line. Okay, so you draw your tangent line, you extend it out as far as you need to until it goes through some nice grid points. The proper term is lattice point, by the way. We'll call them grid points. And then you simply find the slope. So this point right here is at 9, 10. This point right here is at 5, 2. And so what is this tangent line here going to be? I got my slope formula. It's going to be 10 minus 2, right? Change in y's. 10 minus 2 over, change in x's, 9 minus 5. 10 minus 2 is 8. 9 minus 5 is 4. 8 over 4 is 2 meters per second. That is what the instantaneous velocity being. You should be watching. Put away the phone. I know your mom's not a physics teacher. That is the instantaneous slope at that point. We don't even know what time that point is. We're guessing. That's how fast it's going right there. How fast is it going relatively before? Is it slower or faster before? How can you tell? Not as steep, right? Flatter. Speeding up before. So down here it's like maybe 1.5. Here it's like 2.5. That is the speed at that instant. When the person looks down at the speedometer, that's how fast they're going. Okay? How did I do it? I drew my tangent line, and I found the slope. That's all. Hard part for kids is drawing the tangent line. Oh, here's right here. The inst is the slope of the tangent line, and you pick any 2 points on the tangent line. Any 2 points. I'm going to say it one more time. Any 2 points. Guaranteed, at least 5 of you will say to me sometime in the next 2 days, doesn't matter what points I pick, and I will say any 2 points. How come? How come I can also pick, say, these points right here? Because it's a straight line, right? The slope doesn't change of a straight line. You can pick any 2 points. Okay, now there's a special name for this. When the dt graph is curved like this, this is called variable motion because the velocity varies. Variable motion or accelerated motion. It's speeding up or it's slowing down. If this is called variable motion, what would it be called? I'll come back to this right away. What would it be called when it's a straight line Straight line like this. When it's moving at a constant speed, you call it constant motion. Oops. Okay, constant motion. This, when it's curved, is called variable motion. It varies. Okay, I think, are there 3 practice questions, am I right? Or just 2? 3? Okay, you guys try that very first one. I'll wander around and offer assistance. You need to find this instantaneous slope at that single point. How's that for a tangent line? For the first one, does that work? Say again, Anna? No? No? You can draw it as long as you want, you can draw it as short as you want. Okay? When they start, how many people are in pre-calculus? Which means you're probably taking calculus at some point, right? So that's what, well, why would you take pre-med if you're not going to med? That's another rant for another day. Eventually, when you take calculus, they're going to start talking about limits, and they will talk to you about tangent lines just like this. And they will do a zoom in kind of thing, and they'll talk about this curved line. And if you go small enough, if you zoom in far enough, that curved line becomes straight. And then you take that straight little part and you stretch it out, and that's a tangent line. So you might hear that when you take calculus. And you can think of me with fondness and say, man, I wish it was that easy back when I was in grade 11. Anyway, so you draw your tangent line, and then you pick 2 points. Now, unfortunately, I didn't really have any grids on here, do I, right? So we're going to have to sort of estimate. I'm going to just do it like this. I'm going to go up from 6, and I'm going to call this point here 6, comma, what would you say, 22 maybe? Will I go 8 and 25? Okay. Will that work? I think it's a little bit above 25, wouldn't you? Does it matter what your points are compared to mine? Okay, so my point here is that, you're going to pick slightly different points. Your tangent line is going to be a little bit different than your neighbor's, isn't it? Is that okay? And the answer is yes. I look for a process. I don't care if your number is the same as mine. Now, should it be ballpark the same as mine? Yes. If I get 4 meters per second and you get 133, there's a problem. If I get 4 and you get 6, not a problem, as long as I see the work. So we'll go with maybe not 6 and 22. I'm going to go with 8 and maybe 27. You could even say 27 and a half if you want. Now, can I pick that point as one of my points? Is that okay? Any 2 points on the line. Any 2 points. Just for fun, I'm going to pick that point right there, just to show you. Okay, so I'm going to call this point 2.5 and 15. Okay, so what's the slope? So it's going to be 27 minus 15 all over 8 minus 2.5. And Jason has stolen my calculator. So 27 minus 15, I'll have to do it in my head. 5 and 7 is 12. And 8 minus 2.5, 8 minus 3 is 5. So I'm going to go, it's going to be 5 and a half, right? What's 12 divided by 5.5? I can't do that in my head, sorry. 2.18. 2.18 meters per second. Did you get 2.18 meters per second? Really? 2. Is that close enough? Absolutely. Now, guaranteed there's going to be some people are going to say, is this close enough, Mr. Bennett? Use your judgment. What's kind of the ballpark around 2? Well, it can't be 0 because that would be flat, right? It's probably got to be bigger than 1 and less than 3, roughly. If you got 3.1, that's okay. Maybe you're just a bad tangent line drawer. At some point, I will say, your tangent line sucks. I'm not giving you full marks. Okay? But that's my judgment. Jason had a real good question here. How many people started practice 2? Anyone? Few? Okay. So what happens in a situation like this? Like, remember, I have to estimate the slope of the line, right? So I'm going to just kind of do that like this, and then I'm going to drag it down. Is that? I'm going to go a little steeper. How's that? You comfortable with that? Okay, you'll notice that it crosses it down here. Is that okay? No? It's okay because the slope of the line turns. Really what we're trying to do is we're trying to come up with an estimate for the slope. Does this matter? Like, what if I just draw the line shorter? Is it the same line? Yeah, okay. So this is kind of like out of play, it's out of bounds, it doesn't really matter a whole lot. It doesn't have anything to do with this part of the graph here. Now Vinny's just doing a bad job of hiding his phone. What is so important on there, Vinny? Am I that boring? Yeah. Am I? The door is real close to you. Yeah, well, you got to put it away, man, because it's going to get hard and you're going to struggle. I guarantee it. I've been down this road many, many times. Pick any 2 points. What if they're off the graph? What do you do? Yes. You could guess. Is it okay to do this? Is it okay to pick 2 points down on one side? Can I be so crazy and do that? Is that okay? Any 2 points. Any 2 points. I'm going to call this 6, 16, and I'm going to call that 2, 9. 16 minus 9 all over 6 minus 2. 16 minus 9 is 7. 6 minus 2 is 4. 7 quarters is 1.75 meters per second. What'd you get? Is that close enough? Of course it is. What would be the range that I would accept? It's got to be bigger than 0, right? Probably anywhere between 1 and about 2.5 would be fine. How much different is this than yesterday? Or sorry, the day before? The only thing that's different is you're drawing in that tangent line. That's the only difference. Okay. This one here, you're supposed to do 3 of them. Okay? So do 3 tangent lines. If you want to draw and then erase, you can. I'll give you a few minutes for that, and then you're into the practice stuff on your own. Go. Oh, it does just say 1, 2, 3. Okay. All right, well, we'll do number 1. Is that line okay for number 1, do you think? This one's a little bit easier because I got a grid on there, but I don't really see any good lattice points. I'm going to go with this one and that one. So slope at 1 is going to be, let's just see here, about 1.5 minus, it's going to be about minus 0.4, minus a minus 0.4. So that's plus, so that's going to be up 1.9, and the time here is 3 minus 0. So 1.9 over 3. Jason, help me out. You got my calculator. 1.9 divided by 3. It's going to be like about 0.64 or something like that. 0.63. Okay. Is that close enough? Yeah. Did you show the work? Did you draw the line, show me 2 points, and draw the slope? If you did that, then that's good enough. At 2 seconds right here, I don't like that line. I want it to be steeper. Okay, so let's go with, oh, that's a good one right there. And I don't know. We'll go the end point because I know people like the end point. So I'm going to call this 3.8 comma 3.5, and I'm going to call this one here 1 comma 0. So that's going to be 3.5 is the y minus the y here is 0, and 3.8 minus 1. So that's going to be 3.5. 3.8 minus 1 is going to be 2.8. So Jason, 3.5 divided by 2.8, it's going to be about how much? 1.25 meters per second. It certainly has to be bigger than that. You could probably estimate the next one. It's probably going to be about 2. Did you guys get around 2? Yeah. Yeah, 1.6. Okay. Relatively easy. Okay, everyone feeling good? Okay, awesome. Okay, so you've got about 18 minutes left. There are how many graphs at the end there? There's quite a few, I think, right? There's lots. Here's something that I tend to do. I give you lots because there's always someone that wants more. So don't feel obligated to do them all. At the very least, you should do A, but I will point out that A doesn't have a curved one. So maybe you should do B instead of A, because they got curved ones there, right? At the very least, do one of those with a curve. There are answers on the very back page. There's a QR code with solutions. Okay? You got a little bit of time to practice. Kind of a summary of things we've done up to now. Okay? And I'm happy to take questions too during this time. Sure.